We on to problem number 7 of round 1 of the 2015 MIT integration B, which is the definite integral from x equals -1 to x equals to 2 of the absolute value of x squared minus a quarter. It seems like an easy problem. Sadly, none of the contestants was able to solve this problem. So let's see how we may be able to solve it. Let's have a visual representation of y equals to x squared minus a quarter. As you can see, at around 0, y is a quarter, and then the graph crosses 0 at x equals to -1/2 and x equals to 1/2. Now, when you put an absolute value on that graph, the negative value flips to the positive value. And the interesting thing you can see here is that the area that we're required to deduce, which is from -1 all the way to 2, we see that from -1 to +1 here, everything is symmetrical. So we could as well just integrate from x equals to 0 to x equals to 1 and double that, and then go to have a single integral from 1 to 2. And that's what we're going to do. So our integral, which is initially split in all these regions from -1 to -1/2, -1/2 to 0, 0 to 1/2, and 1/2 to 2, can now be bunched together. So we have twice of the same integral from 0 to 1/2, where we've put a negative sign to flip whatever we had, and then from 1/2 to 1, we have twice of the same integral, and then from 1 to 2. So this integral negative of x squared minus a quarter just becomes a quarter minus x squared, and obviously everything remains the same. So a quarter minus x squared is a quarter x minus x cubed over 3, obviously twice from 0 to 1/2, then twice x squared minus a quarter is the same as x cubed, integrated is x cubed over 3 minus a quarter x, twice from 1/2 to 1, and then similarly x squared minus a quarter is x cubed minus x cubed over 3 minus a quarter of x, where we've missed that, from 1 to 2. So that becomes that, and then we just substitute in the limits. Upper limit here we have 1/2, so a quarter times 1/2 minus a third times 1/8. That is 1/2 to the power 3, plus twice we have on the upper limit 1/3 minus 1/4 minus a third times 1/2 cube, which is 1/8 minus a quarter times 1/2. And here we have 2 cube over 3, which is 8/3, minus 2/4 minus 1/3 minus a quarter. The next thing we'll do here is just, this is the same as 1/8, this is the same as 1/24, and this is the same as 12 in the denominator, 4 minus 1, so 1/12, and this is 1/24 minus 1/8, and here we have 12 as a denominator. 12 divided by 3 is 4, 4 times 8 is 32, 12 divided by 4 is 3, 3 times 2 is 6, so 32 minus 6, minus here 12 is the denominator of 3 of this fraction, the LCM, and so we have 12 divided by 3 is 4, 4 minus 12 divided by 4 is 3, 3 times 1, so 4 minus 3. And then we can go here and just combine everything here. So we have 2, 24 being the common, the LCM here. So 24 divided by 8 is 3, 3 minus 1. Plus again here, we want to focus on here. 24 is LCM, 24 divided by 1 is 1, 4 divided by 8 is 3, so 1 minus 3. And then here we have 32 minus 6 is 26, minus 4 minus 3 here is 1, so 1/12. Then we can go and say that we have common LCM here. 24 divided by 12 is 2, so we have 2 here. 1 minus 3 is negative 2, and 26, since we have a common LCM, common denominator here, we just have to have 26 minus 1, which is 25. And so having a common denominator of 24 means that we have 3 minus 1 is 2, 2 times 2 is 4. Here we have 2 minus 2 is 4, 4 times 2 is 8, so we have 8, and 24 divided by 12 is 2 times 25 is 50. So 50 times 8 plus 4 is 62 over 24, and the answer is 31 over 24. And that is the answer that we're looking for.